Okay, so now I'm going to be talking about the pressure versus time graph. And the pressure versus time graph, it gives you some information that is also useful. So we'll start where the aortic valve opens. And that's where it's marked right here, red. So the aortic valve opens, where did we see that before? We saw that when during the ejection phase of, well, the rapid ejection phase of the left ventricle, and that can be seen right here, the rapid ejection phase. Okay, it describes you this how long it goes for and the pressure difference as well. So the aortic valve opens at 80 in this graph. It opens at 80 millimeters mercury. So what does that mean? Where do we see that 80 millimeters mercury before? Well, let's think. That usually occurs during diastole, right? So, but we looked at the graph before where diastole was here. Now, isn't that right? Well, not exactly. The end diastolic volume, that's different, ends here. But the diastolic pressure is the point at which the blood pressure after contraction, so the contraction started here, but it still hasn't opened. So still, in other words, the chambers are still refilled with blood, even though there's no more refilling. It's the point until the valve opens, okay? So that's the diastolic pressure. And so the systolic pressure is easier to understand as it's just the highest pressure during contraction. And that occurs around 120. So that's why you always see 120 over 80 being the normal systolic and diastolic blood pressures that can be seen. Okay, and so what can be extracted from that? Well, the pulse pressure, where it's just the difference between the systolic and diastolic pressure, and that's usually around 40 millimeter mercury. That difference. All right, so that's that. We can also discuss about the heart sounds that can be observed in here. And so there are two heart sounds normally. That is the S1 and the S2. S1 represents the mitral valve closing, and we looked at that will occur right before the ventricle contraction. Okay, and so the closure of the mitral valve will start the systole part of the cardiac cycle. And so, or in other words, that's the S1 is more like it's like the it's right here. So right before it opens. I think I said it perfectly then. The S2 sound occurs when the aortic valve closes. So that's at the end of the ventricular contraction, right before diastole, right before the filling of the blood into the left ventricle. Okay? And the S3 and S4 are hard to hear with the stethoscope, and I'm not going to be discussing that in here. Okay, so next thing to look at is this portion of the aortic valve that occurs. Sorry, the aortic pressure that occurs at the aortic valve once it closes. So there's a little, they call it like it says here, dicrotic notch. The dicrotic notch occurs due to it's just a brief increase in the pressure of the aorta, and that is usually due to the closure of the aortic valve. Okay, so when that closes, there's the elastic recoil of the heart. So, sorry, not of the heart, of the aorta. The elastic recoil of the aorta, it's like its elasticity, meaning once it has been stretched, it's going back into its normal length, and that changing in length gives an additional increase in pressure. Okay, so what's it called? That brief increase in aortic pressure, uh, it's like it makes sure that it actually exceeds the ventricular pressure. Okay, that's why we see this here drop all the way down, and that allows the mitral valve. Sorry, that doesn't allow the mitral valve to open, but it does allow the aortic valve to actually close fully. Okay, so make sure we know this so that we understand the physiological variations that we'll be talking about next.